Composition and inheritance basics. Inheritance is another strategy we use in order to reduce duplicate code. Inheritance allows one class to inherit member variables and functions from its parent. Let's say we are designing an operating system and we will need to store files, but there are different file types: images, sound, video, etc. While the actual data for an image is different from the data for audio, there is file information that all file types will have: file name, extension, size, creation date. Any of the shared data we could store in a parent class, aka a base class, storing the variables and functionality for those common items in one place. From there, we could create our child classes, also known as subclasses, to define more specialized versions of files, implementing only what's special about that file type. To use inheritance, we would begin by creating our parent class, aka base class, with the shared functionality. In this example video game, all characters will have XY coordinates and a width and height and a name. From there, we can create a child class, subclass, for a player character. We can override the move function, which would probably make use of a function to check keyboard input in order to move our character. We can also create a non-player character child class, which also overrides its parent's move function. Our NPC would rely on video game AI to decide how it moves. So by using inheritance, we've stored attributes and functionality common to both player characters and non-player characters in one place, then added the specialized code for keyboard handling or AI decision-making to the child classes. When we use inheritance, parent members that are marked public or protected will be accessible by the child class, just like they were its own members. But any parent members marked private won't be accessible by the child classes. Inheriting the variables and functions of another class can create messy code as the family tree grows, and we lose the nice compartmentalized nature of our code because it all gets jumbled in together. Composition is a different way to handle class relationships. By putting one class inside another class, we can still reuse code in common between the types, but that generic code will be stored as a member variable of the specific class, rather than as a parent. Let's put our reusable code in its own class. For this video game, every game object would need a position and dimensions, so we put this in a physical object class. Instead of inheriting, we add the physical object as a member variable within our player character and non-player character classes. Then, within a function like player character's move, we can call upon the physical object member variable. This way, code relating to coordinates and dimensions stays compartmentalized in the phys member variable. Inheritance is known as a is-a relationship, while composition is known as a has-a relationship. These are just additional tools in our toolbox to help us write less duplicate code and hopefully make code that's easier to maintain over time.